Inside silicon, the technology behind everything.
When we talk about AI, we think of things that feel, well, almost magical, right? We've got chatbots that can rate poetry, cars that drive themselves, software that can diagnose diseases. It all just feels so digital, so intangible. But today, we're going to pull back the curtain on that magic trick.
Okay, let's just pause on that for a second. This one sentence really cuts right to the heart of a huge misunderstanding about artificial intelligence. The honest-to-goodness truth is, without the physical reality of silicon chips, AI is completely useless. I mean it. No chips, no computation, no AI. Simple as that.
So, what is the secret? In this explainer, we're going to look right past all the hype and uncover the hidden physical foundation that makes all of this incredible technology even possible. Let's really dig in and find out what's going on behind the scenes. All right, so to start, we really need to tackle a popular myth that's floating around out there. The idea that AI is just about clever software and massive amounts of data. And look, while those are absolutely important, they're really only 2/3 of the story. The reality is, AI actually stands on 3 pillars. First, you've got the algorithms. That's the clever software. Then you have data, which is basically the fuel for that software. But then you have this third, often forgotten pillar, compute. This is the physical engine. This is where the silicon comes into play. And this is where we ground AI in actual physics. See, every single time ChatGPT spits out an answer, it's because trillions of tiny mathematical operations are being physically executed by transistors inside a silicon chip. It's not some abstract thought process. It's just raw, physical calculation happening at a scale that's almost impossible to comprehend. So if AI is really all about physical computation, what kind of hardware is actually doing all that heavy lifting? Well, let's meet the team of specialized silicon that makes it all happen. First, you've got your CPUs, which are kind of like the general managers of a computer. They're great for all sorts of tasks, but they aren't really built for the specific kind of math that AI needs. And that's where GPUs come in. Funnily enough, they were originally for video games, but their ability to do thousands of calculations all at the same time, what we call parallel processing, makes them absolutely perfect for training AI models. This right here is precisely why a company like NVIDIA has become so incredibly dominant. But it's not just about GPUs. You've also got specialized AI accelerators, like Google's tensor processing units, or TPUs, that are built for maximum efficiency. And just as important are the memory and the interconnects. Think of them as the superhighways that move data around. Because really, it doesn't matter how fast your processor is if it's just sitting there starved for data. Now, all this specialized hardware is at the very center of a relentless race. It's a race to make the fundamental building block of these chips, the transistor, smaller and smaller and smaller. And this entire race is measured in nanometers. So when you hear people talking about 7 nanometer or 5 nanometer chips, what they're referring to is the technology node. It's basically just a measurement of how tiny the transistors are on that chip. And the rule is simple. The smaller the node, the more advanced the chip. And right now, the most advanced chips in the world are being built on a 3 nanometer process. Now, to put that into perspective, a single human hair is about 80,000 nanometers wide. We are literally building machines with components so small they are approaching the scale of atoms. It's truly mind-boggling. So why does this matter so much? Why the obsession with going smaller? Well, because smaller transistors give you 3 massive advantages. You can pack more of them on a single chip for more power. They consume way less electricity, which is absolutely critical for those giant data centers. And you get more performance for every single watt of energy you use, which is maybe the single most important metric for AI today. This physical dependency completely changes the question of who's really winning the AI race. It's not just about the big software companies you hear about every day. No, The real power lies with the companies that control the physical supply chain. First, you've got a company called ASML in the Netherlands. Now, they are the only company in the entire world that builds the incredibly complex EUV lithography machines required to manufacture these advanced chips. If they stop making their tools, the race just stops. Then you have TSMC in Taiwan. They are the master builders. They take the designs from other companies and use ASML's tools to actually manufacture the world's most advanced silicon at an unbelievable scale. And of course, you have NVIDIA, the architects. They're the ones who design the chip blueprints that set the standard for AI performance, which are then built by manufacturers like TSMC. Every one of these players is an essential, totally irreplaceable link in the chain. So, this all illustrates the new reality we're in. The global competition over AI isn't just about who can write the best code anymore. It's about who controls the fabrication plants, who controls the manufacturing tools, and who has the deep expertise needed to produce this bleeding-edge silicon. After looking at all of this, the hardware, the manufacturing, the global supply chain, what's the single most important thing to take away from all of it? It's this. Artificial intelligence cannot exist as some free-floating entity up in the cloud. It will always require a physical substrate to run on. It needs a body to compute. And today, and for the foreseeable future, that body is made of silicon. The entire digital revolution is and always has been built on a physical foundation.
Inside silicon, the technology behind everything.